make sure you can hear the sound on this video. I put this sign up so that those people who can't hear the sound at least make an attempt to make it happen. Okay, so this is in the Chapter 1 study guide in geometry. This is Chapter 1, Section 5, Part 2. We're going to talk about a couple of concepts that have to do with angles, and the first one actually carries over very similarly to something we did in the previous lesson in Section 151. The previous lesson talked about, at least in part, something called supplementary angles. Supplementary angles add up to 180 degrees. But I mentioned that just calling them supplementary didn't mean that they had to be next to each other. Supplementary angles, as long as they add up to 180, they're supplementary. So I drew a couple of examples. I drew an example of a pair of angles that are next to each other, kind of. These are adjacent. These are not. They're just kind of drawn on the same page, but they're separate. You see that? Whereas these are adjacent angles. So while both of these are examples of angles that add up to 180 degrees, these are supplementary. These are two things. We could call these both supplementary and a linear pair, because two angles that add up to 180 degrees and exist right next to each other like this are called a linear pair. This is a linear pair of supplementary angles. This is not a linear pair of supplementary angles. They have to be both supplementary and next to each other to be called a linear pair. So here's how I would define a linear pair. They must add up to exactly 180 degrees and be drawn next to each other. So if I drew a picture of that, of a linear pair, it might look something like this. You can see the straight line here. This angle and this angle add up to 180 degrees. Remember that when two angles form a straight line from one side all the way over to the other, that's automatically going to be 180 degrees. The other concept is something called vertical angles. Now this does not carry over from the previous section. This is a very new idea. Vertical angles are two angles on an intersection. So again, it's a pair of angles on an intersection that exist on opposite corners. So if I drew an intersection of two lines like that, then this angle and this angle would be a vertical pair. You'd call those two vertical angles. Or these two angles, this one and this one, are also a vertical pair. Vertical angles are something called congruent. That means they have the same measure. So if this one is 35 degrees up here, then if these are two straight lines, yeah, this one would also have to be 35 degrees down there. Or, as I mentioned before, this is another vertical pair, this one here and this one here. They're on opposite corners of an intersection. And this could be 145 degrees. And that one would also be 145 degrees. So it says in example 4, please identify a pair of linear angles. Okay, remember linear have to add up to 180 degrees, and they have to be a pair. So that means that there's two of them. So are there any two angles that add up to 180 degrees that form just a pair together? So a linear pair? Well, I see angle 2 and 3. They form a straight line from one side to the other. They both look like they're 90 degrees, so yeah, they add up to 180. We don't know for sure that they're 90 degrees since there's no markings on here to indicate that, but we know for sure that they're 180 because they go from one side of a straight line all the way over to the other by adding the two angles together. Another linear pair would be angle 1 and 2. Those two together would form a straight line from one side to the other. Now, we could not say angles 1, 5, and 4 are a linear pair, even though they add up to 180, because there's 3 of them. They don't form a pair because for a pair to exist, there has to be 2. That's what pair means. 2 angles. Are there any vertical angles? Well, it looks like angle 1 and angle 3 are on opposite corners of an intersection. Angle 1 and angle 3, that's a vertical pair. But I don't think we have any more. There aren't any angles that are exactly across from each other on an intersection, because 4 and 5, you know, are together, but there's not one exactly across from 5 or exactly across from 4 that would be the same amount. So 1 and 3 are the only vertical angle pair example that we have. Okay. So let's do some examples using algebra to apply these concepts. Alright, so number 14. It seems to me like if this is 90 degrees here, and this forms one big straight line from this side to that side, if the whole thing is 180 degrees, and this side is 90 over here, wouldn't this side have to be 90 from here to here? This side's 90, that side's 90, you see? Because 90 and 90, this side and this side are 90 both, they'd have to add up to 180 exactly. So I'm basically just going to focus on the left side. I know that this section from here to here is 90 degrees, and I know that it's made up of 2 parts. Now they didn't give us directions here, but basically what they'd like us to do is find, well, I just have to guess here what the assumption is. Let's find the measure of angle ABD and the measure of angle DBC. Okay? Alright, so if that's our ultimate goal, what I would first need to do is find some sort of relationship that's true. Here's what I see. I see 2 angles here on this side. If I add the 2x degrees angle with the 3x degrees angle, that would give me this whole thing. And I know that this whole side is 90 degrees. So that's my statement of truth. I know that adding that angle down here plus this angle right here gives me a total amount of rotation of 90 degrees. So I can add these 2 like terms together and divide by 5 on both sides, solving for x to be 18. Now, that's not the directions. You see the directions are asking us to find these 2 angles here. So we'll have to do a couple more steps. The measure of angle ABD is represented by the algebraic expression 2x, but we can substitute our now found value for x to be 18 and multiply 2 times 18 to be 36 degrees. Finding the other angle, you can either know that these 2 angles add up to 90 and say 90 minus 36 to get this angle, or you can take 18 and multiply it by 3 to to get your answer. I'm going to do it that way. The other angle is represented by the expression 3x. Multiplying it by 18 gives me 54 degrees. So there you go. I found both angles, this one and that one. What I see in number 15 is I see a straight line here. So I know that, just like over here, that half a circle is what I see. So I know that all the way from this side over to this side is a total of 180 degrees. So the relationship that I see as something that's true is that this angle right here, if I add that to this angle over here, I know that the total of the two of them is 180. So again, I'm going to assume that they want us to find the measures of the two angles. They want us to find the measure of angle ABD and the measure of angle DBC. So first I'll use the thing that I see it's true. I see this part plus this part gives me the total of 180. So my first angle part plus my other angle part gives me a total of 180. So I'll have to set up this equation and then solve for x first. Then I'll be able to go back and figure out the actual measures of these angles by using my newly found value of x. 4x plus 11x is 15x. 6, take away 6 is nothing, so those cancel each other out. So if I take my 15 and divide it on both sides, then I get an x value of 12. Now, that's not our final answer. We want to find the measures of these two angles. I'm going to start with the measure of angle ABD. That can be found by using the expression name that was given to us, 4x plus 6, and substituting in 12. So 4 times 12 is 48, and if I add 6 to that, I get 54. Now, since this other angle is just what's left over, if this one's 54 right here, if I know the two of them together add up to 180, I can take 180 minus 54 and get this angle here. It's an angle bigger than 90. It's going to be 100 something. So I would say that the measure of angle DBC, again that's this one, would be most easily quickly found by simply taking 180 and minusing 54 from it, giving me 126 degrees. Now the other way to find that answer would be to take our x value of 12, substitute it right here, multiply it by 11, and then take that answer and subtract 6, and you should get 126 degrees. Okay, example 5. Two angles form a linear pair. Okay, remember a linear pair has two qualifications for it to be a true linear pair. You have a pair of angles that add up to 180, right? And they're next to each other, right? So you can see here in the diagram they have two angles that are add up to 180. Remember when you can envision them being a half a circle because they're a straight line here. That is truly 180 degrees. And are these two next to each other? Absolutely. This one right here is right next to this one over here. So it says that if the measure of one angle is 4 times as big as the other, they must be talking about this big one here. So if this one's x, then 4 times as big as x could be represented by the algebraic expression 4x. X multiplied by 4 is 4x. So if we want to find the measure of each angle, first we have to know what to call them. the bigger one is 4 times as big as the other one, this one's x, then that would be 4x. And if these two angles are a linear pair, that means they're going to add up to 180 degrees. So, I'm just writing 180 up here. If I take the x angle, that's the small one, and I add that to the other angle, that's the big one, then these two angles together, this one and this one, would be 180 degrees. Now, x is the same as 1x, so when I add 1x plus 4x, I get 5x. And dividing both sides by 5, I get 36. Now, that is actually one of our answers. Many times when we solve for x, that's not our final answer, but in this case, it actually is. One of our angles is just plain old x. So, the measure of my first angle is actually 36 degrees. The other one is 4 times as big, so we could simply say 4 times 36, which gives me 135. No. Yeah, 144, excuse me. I'm looking at my cheat sheet. Okay, 144. Duh. There we go. They're supposed to add up to 180. That makes more sense. There we go. Now the other way to do that would be to say that if they add up to 180 degrees and the first one's 36, you could take 180 minus 36 and you'd get the same answer. Just two different ways of thinking about how to find the last answer. And either way is perfectly good. All right, the last answer for the day, or the last, example for the day, is basically the same as the one we did up here. The only difference is that the bigger angle is 3 times the measure of the other one. So they're still a linear pair, which means they're still going to add up to 180 degrees. If one of them is 3 times the other one, you could say that if the smaller one is x, and the other one being 3 times as big would be 3x. And so if they're a linear pair, again, if you add up your smaller angle plus your bigger angle, that means that they have to be total 180 degrees to be a linear pair. So, solving this one, x turns out to be 45. And so the first angle is 45 degrees. The other one would be 3 times that amount, or 135 degrees. You could also find the second answer, if they add up to 180, by taking 180 minus 45 to get 135.